going to continue our discussion about lines today, but we're going to take a look at two big ideas, slope, and then also the slope-intercept form of a line. So I have the formula for slope written down in your notes. It's defined to be rise over run, or the change in y over the change in x. So I'm going to show you what I mean by that formula using a couple of different examples. If we want to find the slope and we're given a graph, what we can do is we can pick 2 points on that line, any 2 points, but you want to pick points that kind of go through the corners of these boxes so you can actually read those numbers off. And then the idea is the slope describes the steepness or the slant of that line. In example 1, to get from one point to the next, it looks like we have to go up 2 units and then to the left or backwards 3 units. The rise is the amount we have to go up, so that's going to be 2, and the run is the amount we have to move horizontally. I'm going to call that a -3 because I had to move to the left or backwards 3 units. So that means my slope, which is rise over run, would be 2 divided by -3, and you could actually just write that as a -2/3. One thing to notice here is that the slope is negative when the line is going down, if you read it from left to right, or you could say that the line is actually decreasing. In example 2, if I pick 2 points, pick this one and then maybe up here. So it looks like we have to go up 4 units, and now this time we have to go to the right 3 units. Because slope is rise over run, it would be 4/3. This time I get a positive slope because the line is going up as we read it from left to right. Now, the second part of this formula describes how you can find the slope if you're not given a graph, although we could actually use that formula in these problems as well. Notice that the first point that I chose was x = 1, y = 2, and the second point I chose was x = 4, y = 6. This formula up here is saying that I could subtract the y values. So if I say my first point, x1, y1 is 1, 2, and my second point, x2, y2 is 4, 6, plugging those numbers into the formula, I get y2 minus y1, so 6 minus 2, divided by x2 minus x1, 4 minus 1, and that gives me the exact same answer of 4/3. That second part of the formula is going to be really useful if we're not actually given a graph. In my next 2 examples, I have our 2 special cases. This is actually the horizontal line y = 4. In this case, if I compute the slope, to move from one point to the next, I don't have to go up or down at all. I only have to go over. So I guess my slope would be, how I've drawn it, 0/3 or just 0. And in fact, horizontal lines always have a slope of 0. So if you recognize that, you don't have to do any work. You can just write down slope is 0. Now for vertical lines, this is in fact the line x = -2. In this case, the run is actually 0. We only move up or down. We don't move left or right. And because run goes on the bottom of our slope computation, in this case my slope would be 3/0, well, division by 0 is undefined. And in fact, vertical lines always have an undefined slope. You could think of it as the vertical line is infinitely steep. It's like a cliff. The horizontal line is flat, and that's why it has 0 slope. Now, if we're not given a graph, if we're given 2 points, the easiest way to find slope is going to be to use that second part of the definition. We can pick one of our points to be the x1, y1, and the other point to be the x2, y2. It actually doesn't matter which point you call number 1 and which one you call number 2. But once you make that choice, you can just plug the numbers into the formula. So y2 minus y1 is -1 minus -3, and x2 minus x1 is -2 minus 4. This becomes 2/6, and we are going to reduce that to a -1/3. Now we can use the exact same formula even if we have fractions. That just makes the arithmetic a little bit harder, so let's take a look at an example. My slope is going to be y2 minus y1 over x2 minus x1. Now, to do the subtraction, I'm going to have to get some common denominators. 1 is the same thing as 3/3, So 2/3 minus 3/3 is -1/3. And then in the denominator, my LCD is just 2. So I get 6/2 minus 1/2. That's going to be 5/2. So we're left with -1/3 divided by 5/2. To divide fractions, you copy dot flip. So I change it to multiplication and flip the second fraction. To finish, I can multiply straight across, and I end up with a -2/15. And that's my final answer. Slope is -2/15. Let's take a look at an application problem that involves slope. This problem says, a university researcher is conducting an experiment on a bacteria colony to test the effectiveness of a new antibiotic. 3 hours after the antibiotic is administered, the population is 11,500. 2 hours later, so that's 5 hours after we started, the population is 9,250. Part A says find the slope of the line passing through these 2 points given. So in fact, the words don't even impact what I do in part A. I can just use my exact same slope formula. I'll call the first point my x1, y1, and the second point my x2, y2. And so I'm going to take my change in y divided by my change in x. I get -2,250 divided by 2, or -1,125. Now the words are going to matter when we do part B. Part B is asking us to interpret slope as a rate of change. And slope is always some kind of rate of change. It's always how are the y's changing with the x's. So the easiest way to do part B, I think, is to figure out what are the units. And so notice the y values. Those are populations. Population of a bacteria colony. Whereas the x values, 3 and 5, describe the time, and that would be hours after we administer this bacteria. So that tells me that the units of my slope is actually bacteria per hour. Because I have a negative slope, the amount of bacteria is decreasing. And so I could say that the bacteria is decreasing at a rate of 1,125 bacteria per hour. The second thing I'd like to talk about today is how can you find the slope if you're given an equation of a line? And so I'm going to start by giving you a formula called the slope-intercept form of a line. The x and the y are variables. The m stands for slope, and the b is the y-intercept of the line. That's why this is called slope-intercept form. So if you have an equation that's solved for y, just like I do in example 5a, I immediately know the slope and the y-intercept. In 5a, the slope has to be 3, or 3/1, because that's the number in front of the x, and the b, or the y-intercept, is -5. Now notice that slope-intercept form had that equation solved for y. So if I want to read the slope and the y-intercept off of a line, I have to actually take that equation and solve it for y first. And so in part B, because that equation is not solved for y, we have to get the y by itself. I'm going to do that by first subtracting the 2x. That gives me -5y equals -2x plus 10. Notice the 2x and the 10 are not like terms, so I can't combine them. And then I'm going to go through and divide everything by -5. That gives me a +2/5 x, and then 10 divided by -5 is -2. I have this equation now in slope-intercept form, and so I know that my slope is 2/5, or 2/5, and my y-intercept is the constant -2. We can actually use the slope and the y-intercept to help us graph lines, and in many cases this is going to be a lot faster than making a table of values. In 6a, this equation is in slope-intercept form. I know the slope is the number in front of the x, the 1/2, and the y-intercept is the constant, 3. So if I want to graph this line, I could start by plotting the y-intercept, going up to y equals 3. And then because the slope is 1/2, rise over 1, run, I would go up 1/2. And I could even repeat that a couple times to help me draw that straight line. I could also go down to 1, backwards 2 if I wanted to. And so in red, there's my graph, my final answer here. Now if you want to use the slope and the intercept to graph a line, you do have to make sure the equation is solved for y. And so in example B, I have to start by getting the y by itself, which means we have to subtract the 3x. Once the y is by itself, I know the slope is negative 3, and the b, or the y-intercept, is 4. Now this is actually a negative 3 over 1. So I'm going to start by plotting my y-intercept at 4, y equals 4, and then because the slope is negative 3 over positive 1, I would go down 3 over 1. Notice when you have a negative slope, the line should be decreasing or going down, whereas when you have a positive slope, the line is going to be increasing or going up. We can even use this slope-intercept form to write equations of lines. If I know what the slope is, and I know what the y-intercept is, I can just plug those things into my slope-intercept form. In example 7, if I want to write the equation of a line with a slope of negative 3, my equation would be y equals negative 3x, and if it passes through that y-intercept of 0, 3, it'd be negative 3x plus 3. In example 8, to find the equation of a line that passes through 1, 5 and 0, negative 2, I know the y-intercept here as well. The y-intercept always has an x value of 0. So the b value here is negative 2. Now they didn't tell me what the slope is, but I could do a little bit of work. I could use my formula, change in y over change in x, and compute that slope. So I'm going to take negative 2 minus 5 over 0 minus 1. That's negative 7 over negative 1, or positive 7. And so my final answer would be y equals 7x minus 2. Y equals mx plus b. Now we can use this exact same process if we're given a graph. If I want to write the equation of this line in y equals mx plus b form, I have to know the slope and the y-intercept. And on this graph, I can actually tell that the y-intercept is at 4, and I can count some boxes to find the slope. It looks like we have to go down 2 and to the right 3. That means my slope is negative 2/3. So this equation would be y equals negative 2/3 x plus 4. That's it for today. We're going to continue with lines in our next lesson, so please let me know if you have any questions on this before we move on.